Hello friends, welcome to the session. Last session we stopped at problem number 12. I think all of you might have followed that, okay? So that's really a special problem to understand how to calculate the current through the inductor when voltage is given. Okay, so it's very important that when voltage is given, we need to find the current. You need to go for area calculation, particularly in the case of inductor, right? In the area calculation, it must be very, very important, okay? So that particular problem will give you a great idea because we are going to see some more problems in the similar lines which were asked in the gate, okay? That we'll see later. And the 13th problem now we start with, you can see that is here it is expected to find LAB, equivalent inductance calculation. It's a very simple problem. So let's try to finish it off here. Look at this, how the elements are connected. So how these 4 and 8 are connected? They are in series. These two are in series. Yes or no? 8 plus 12, that is 20. Yes or no? 20. And 20 parallel 5, that is 4. Okay. Again here, just keep it aside for a moment. And 8 plus 4, 12. And 12 parallel 6, again it is 4. Yes or no? Yes or no, all of you, okay? Then this 4 and this 4, this is actually the 4, right? This particular part is 4. This particular part is also 4. So 4 millihenry and this is also 4 millihenry. And this 4 are again in series. 4 plus 4, 8. And this 8 is parallel to what? 8. That is 4. And now the resultant is 4 plus 6 plus 10 will give you 20 millihenry. So this is what actually LAB value. So it's easy to calculate what we have done in the case of equivalent resistance calculation. The same thing we can do here. Okay. So please quickly copy that. I will just write another problem meanwhile. Quickly note down. 13th problem, that one. Now question number 14. Classroom workbook. It was actually asked in GATE, previous GATE exam paper. It's very interesting problem. Please note down that quickly. Okay. Fourteenth problem. Let me read it. The figure shows the waveform of the current passing through an inductor of resistance 1 ohm and an inductance of 2 Henry. The energy absorbed by the inductor in the first 4 seconds is, okay? So what is asking actually here, the energy absorbed by the inductor in the first 4 seconds is. It means that the energy between 0 to 4, just look at this waveform given in the problem. All of you please go through that. The energy within that 4 seconds, the first 4 seconds, that means 0 to 4 seconds. Energy at the end of 4 seconds, that is also same as energy between 0 to 4 seconds. Understand all of you? Total energy that has been absorbed by the inductor, that is also up to 4 seconds, because 4 seconds is only the highest time that we can observe in the graph here, right? In the waveform here. So students, the current is given and the coil actually, this is not simply an inductor, it is a coil because he has given resistance as well as inductance. So what is the resistance actually given here? It is 1 ohm and inductance is of 2 Henry. This is what actually the inductor, okay, inductor given. The inductor coil is of 2 Henry, 1 ohm. This is called coil actually, okay. Sometimes he will mention it as a coil, sometimes he will mention it as an inductor, but he will give a parameters. If resistance is not given, it is an ideal inductor. But now this is what? practical inductor. Okay. So now let us try to understand. This is what the current given, I of t given. Now what is actually asked here? Energy. What is the energy formula? Energy, if you want to find, okay, W of 0 plus 0 to t, P of t dt. Okay. W of t is equal to, yes or no? W of t is equal to W of 0 plus integration 0 to t P of t dt. Or else you can say it is an area under power. But what's happening here is the current is given. Okay. But here the power is nothing but what? Power is nothing but what? Actually here the voltage and current product. Yes or no? Voltage and current product. Okay. dt. Now let me draw this equivalent resistor and inductor. Okay. This is 2 Henry and this is 1 ohm. This is the total voltage if we assume. And okay, this is the total current I of t. The voltage gets divided because we know that it's a series modeling resistor. Just now in the last class we have seen. So VR of t and plus minus VL of t. Yes or no, all of you? So now what is the power of the resistor here? Instantaneous power VR of t into I of t. Instantaneous power of the inductor VL of t into the same current is passing I of t. Then we need to find the power. Then we have to substitute here. Okay, the product of voltage and current. Then we have to integrate. Then we try to get the answer. Okay, so total power is nothing but actually here is of, okay, WR of t plus WL of t. Understand all of you? So let me first find what is WR of t. WR of t is nothing but what? W naught. But you know that this is 0 because he did not provide any information directly or indirectly regarding the energy, initial amount of energy stored in the coil. So that I can take it as 0 with an assumption. Okay. Now WR of t. Okay. Now till what extent actually is expecting here? 0 to 4. So the waveform you can see I of t is given. First let us define I of t here. Then let us find what is VR of t here. Then we find VL of t here. Then we substitute here. Understand? First let me write. Okay. 0 to 4 V of t, VR of t into I of t dt. WL of t is nothing but 0 to 4 VL of t into I of t dt. Now let me find what is I of t. Actually I of t is defined here 0 to, okay, 0 to 2 seconds is a line passing through the origin, 6 by 2. The slope is 6 by 2. That means 3t for t between 0 to 2 seconds. And it is constant for 2 to 4. So it is actually 6 ampere, okay, for t between 2 and 4. Yes or no? Okay. Now let's find what is VR of t. VR of t is nothing but what? I of t into R. Yes or no? What is I of t here? Simply 1 ohm. Okay. Therefore, you will get again same 3t for t between 0 to 2 and 6 for t between 2 and 4. Okay. All of you look at this. Later I'll give time to note down. Okay. Then VL of t is nothing but what? L d I of t by dt. What is I of t? Actually, d I of t by dt is nothing but 3. What is L value? 2. 2 into 3. This is simply 6 for t between 0 to 2. Okay. Next, what is actually d I of t by dt for t 2 and 4 here? When you differentiate this, it becomes 0. Okay. It becomes 0 here. So 0 into something again 0 only here for t between 2 to 4. Understand all of you? Okay. So this is how you can calculate. Now, let us try to find what is WR of t. WR of t will become now what actually here? We can split because 0 to 2, 2 to 4 you have. So 0 to 2, okay, VR of t into I of t. What is VR of t to I of t actually here? VR of t is 3t and I of t is also 3t. Now 3t into 3t, okay, dt plus 2 to 4, okay, 2 to 4, you have 6 into 6 dt. Yes or no? So what will you get here? Just let me confine myself here to the area like this. Now what will I get here? 3 into 3, 9 t square. T square is nothing but t cube by 3 after integration. So therefore 9 t cube by 3, it is from 0 to 2 plus, what about this? 36 t, okay, 36 t from 2 to 4. Understand all of you, okay? This is very clear that 3 3 ja and 3 3 ja here. This is 2 cube, right? All of you. That means 8. 8 into 3, 24. And here 4 minus 2, that is 2 into 36. That is nothing but 72. Therefore, here 24 plus, okay, 72. It is nothing but 96 watts. I'm sorry, joules. Because it is energy, therefore we must take it in joules. Okay. Now coming to this WL of t here. Now what will you get here? 0 to 2. 0 to 2. What is this? Actually here VL of t is how much? 6. 6 into what? 3t. 6 into 3t. 6 into 3t dt plus. Now what about this? This is 0. Because look at 0 into 6. I'm sorry, 0 into 6 here. Current into voltage. Yes or no? Therefore, what will you get here? 6 into 3, that's 18, 18t, 18t square by 2. 18t square by 2 between 0 to 2. Yes or no, all of you? Now this is 9. Yes or no? Okay, 9. And this is 2 square, that is 4. Now 9 into 4. What will happen here? This is 36 joule. Now when you substitute, okay, this I am actually calculating what WR of t, but it's not simply t, it is actually what WR of 4, because we are expected to find up to 4 seconds. This is also 4 seconds. Yes or no, all of you? Now what is the total W of 4? Is nothing but WR of 4 plus WL of 4 is nothing but how much here? That is 96 joule plus 36 joule. Okay, you get 132 joule. This is what the answer. Okay, among the 4 options given, C is the option that you can choose. I think all of you understand how you need to proceed. Okay, sometimes direct area calculation may not support. Understand all of you, okay? You are supposed to go for, the integration step by step. There is no other option sometimes. Okay, so please note down quickly, all of you. Please note down. Note down that all of you. Note down. So that's very interesting question. It was asked in GATE. It's very important question. It's simple that energy power relationship, that's it. Initial energy is assumed to be 0. For energy, you require power, instantaneous power. For that, you require instantaneous voltage and current for each element, because there is an inductor as well as a resistor. Understand all of you, okay? Both the elements are there, and both of their characteristics are different. That is why instantaneous current, if you know, because they are in series, you can find voltage of each element. Then if you find the product, you will find the power. Once you know instantaneous power, you can directly find instantaneous energy, and then you find the total energy when you substitute t equal to 4 seconds. That's it. So I have taken here WR of 4, WL of 4, total W of 4, simply 132 joules. Let's go with question number 15. This was also asked in GATE. It's very, very interesting question. It's very, very interesting question. There are many problems asked in gate on inductors and capacitors, but I'm particularly selecting some important problems where you generally find difficulty. Okay, all remaining problems are very simple. Hope you have finished this particular part. I'm just taking it off. Note on that quickly. When a periodic triangular voltage of peak amplitude 1 volt and frequency of 0.5 hertz is applied to a parallel combination of 1 ohm resistance and 1 farad capacitance. Okay. The current through the voltage source has waveform. Okay. He has given some 4 options. I think you can observe what kind of waveforms are provided. Okay. Let me draw it. Okay. First here, peak amplitude, how much? Peak amplitude given as 1 volt. Frequency is given as how much? 0.5 hertz. Nothing but time period is how much? 2 seconds. Parallel combination of resistor and capacitance. This is a parallel combination. And here is the, okay, the voltage actually given. So what could be the current he is expecting now? Here, this one. Okay. What is that given actually here? That's given here triangular, right? So triangular. What is it actually here? When a periodic triangular voltage of peak amplitude. Okay. Periodic triangular means it looks like this. Zero 0.5 because 2, right? What is the frequency here? 0.5. What is the time period? 2, right? This is 2. So this is 1. This is 1.5. That's it. So this is in t time in millisecond, and this is now the, okay, this is what the voltage given, right? Okay, voltage, it is in volts. Peak value how much? 1 plus 1. This is minus 1. Okay. So this is what the data given. Now what is expecting actually here? There are some waveforms given. Okay. Let me draw the waveforms just for an idea. Just for an idea. What is asking actually the resulting waveform of what? Current delivered by the source. How the elements are connected here? They are connected in parallel, right? They are connected in parallel. When they are connected in parallel, what is the total current actually here? Total current is nothing but this IR of t, this IC of t. We must find both the waveforms, and when we add these two waveforms, you will get what? I of t. Yes, sir? Okay. So what are the options given actually here? The options are given something like this. Let me write here. Let me draw it. Okay. This is something like a rectangular pulse. Okay. Something like this. B, option B is given. Sawtooth waveform. Option C is given. something like this. Option D given here. Okay. Option D given. I'm just drawing intentionally because just to understand the problem first of all. See, this is a very interesting problem. Okay, let us see how we do it. Something like this. Okay. Now look at this, all of you. What is the waveform given? Triangular wave. When you give a triangular voltage, the current, because I is equal to V by R simply, the current through the resistor will also give you a triangular waveform. Yes or no? Okay. But what could be the current flowing through the capacitor, because I is equal to CdV by dt, then you are supposed to differentiate it. You will get what a square wave or rectangular wave. Let us say rectangular wave. Yes or no, all of you? When you add this triangular plus rectangular, definitely you get combination of these two. You never get a, the resulting waveform as a triangular or rectangular. So obviously out of these four options, I can bluntly remove or rule out, okay, this particular one and this particular one, because this is triangular or sawtooth, whatever, and this is rectangular. What are the options left over? C and D, that we have to investigate now. Understand, all of you? Okay. So let us see now how it is going to be. We draw the waveforms carefully and then we see how we are going to finalize that. Okay. So first let me draw, because I have IR of T is nothing but V of T by R. Okay. Then obviously I get here, what is V of T by R? This is 1 ohm, right? 1 ohm. Then I get a waveform. Here this particular waveform will become same as what the waveform we have received. The voltage waveform, whatever you got, the same thing will be there. Plus 1, and this is what? Minus 1. And this is 0.5, and this is what? 1.0. This is 1.5. This is what? 2. This is T. And this is IR of T now. Understand, all of you? Okay. Now, another one is what? IC of T. The IC of T is nothing but CdV of T by dt. Okay. When you take CdV of by dt, then obviously this is becoming what? When you differentiate this particular one, you get what? Differentiate ramp will become what? Step. Nothing but rectangular waveform you are going to get. Understand, all of you? Okay. So what is the rectangular waveform you are going to get? You know that the slope of this, because you see here, I just draw that waveform also easily. Okay. What is it here? IC of T. Okay. This is T in millisecond. Now, let me draw it. So what do you get here? This is now, okay, how much, what is the slope of it? Slope of it, how much it is? Slope, what do you get? 0.5, yes or no? Okay, 1 by 0.5. So what do you mean by 1 by 0.5? It is nothing but what? 2 only. So 2 volts per millisecond. Yes or no? Okay. What about this? This is also same, right? This is also, but it is a negative slope. This is also minus 2 volts per millisecond. Because the symmetric waveform, you can see here plus 1, minus 1, 0.5, 1, 1.52. What is the slope of it? You can find the slope, okay? Here x1, y1, x2, y2. You know very well. This is 0.5 comma 1. This is what actually here? 1.5 comma minus 1. You please find the slope. I think you understand how to find the slope. I don't need to explain you in detail about that. Okay. So again here, the slope of this particular one will be plus 2 volts per millisecond. Understand, all of you? Okay. So when you multiply here 1 into, okay, 1 into, what is 1 actually here? Capacitance. What is the capacitance value actually given here? 1 farad. Is it 1 farad or 1 millifarad? Let us look at that. Okay, 1 farad, right. So it is 1 farad. Now, what is actually the current actually you are going to get here 1 into, what do you get here? 2 volts per millisecond. Okay, 2 volts per millisecond. 2 volts per millisecond. Okay, what do you get here now? This is nothing but, okay, 2, what do you get here? This current is nothing but C dV of t by dt. What is dV of dV by dt here? What you got actually here? Now 2 volts per millisecond. So when you multiply with the capacitance value, where the capacitance value is given 1 farad here, understand all of you? Okay, you directly get okay, now 2 milliamperes. Understand all of you? Okay, what do you get here? 2 milliamperes. I hope you understand the point here. Okay, so volts per millisecond, okay, volts per millisecond into farad, that you are getting here. Okay, now what about the current here in this particular, one? What do you get here? -2. This is -2, this is +2, this is +2. Yes or no, all of you? So can I say something like this? Here I think I got the current, okay, when you take milliseconds here, okay, amperes, this is actually milliseconds, right? Okay, this is actually millisecond, and you are getting actually not milliamperes, because already milliseconds is there. It's not milliamperes, but let's take it as a magnitude 2. Okay, we'll see that. So what do you get here? IC of t is nothing but this is nothing but what? 2 into, okay, 2 into 1 farad. This is 2. Yes or no, all of you? Now what about this? And then you have negative, what is this? -2, right? It goes up to negative -2, and then it goes up to this, and then it goes up to this. You are going to this 0.5, 1.0, 1.5. This is 2. Understand all of you? Okay. So now, what are you trying to do here? You are going to add these two waveforms. Understand all of you? Okay. So how do you find those waveforms? When you really add these two waveforms, superimpose. Okay. What do you get here? At t equal to 0, at t equal to 0, IR of 0 is what? Actually 0. But IC of 0 is how much here? 2. Yes or no? 2. Now, what about t equal to 0.5? So what is the total actually you get? I is nothing but IR plus IC. So what is that I of 0 you will get here? What is that you get? It is nothing but what? 2 only. Now what is t equal to 0.5 that you are getting here? Okay, what are you getting here? Now here, when you take t equal to 0.5, what is that value actually here? IR of 0.5 is nothing but what? +1. And IC of 0.5 is changing from +2 to -2. Look at this, all of you. This is -2, Nana. Okay, this is changing from, okay, it is changing from +2 to -2. Then what will happen to I of 0.5 here? Okay, yes or no? I think you are getting this particular one. What do you get? +3 to, okay, -2 plus 1. How much it is? -2 plus 1. It is -1. Okay, negative. Then t equal to 1. What do you get here? IR of, okay, because you are taking milliseconds. It is already you are taking milliseconds. Therefore, okay, what do you get? What do you get here? IR of 1 is nothing but 0, but IC of 1 is how much actually here? IC of 1, you got IC of 1, how much it is? Already you got -2, okay, -2. So what do you get? I of 1 actually here, -2 only. Now t equal to 1.5, then what do you get? IR of 1.5 What you can tell me here? IR of 1.5 is how much actually here? -1. And IC of 1.5 is changing from -2 to +2. -2 to +2. Now, when you add these two again, what is that I of 1.5 you're going to get? Tell me. -1, -1, -3. Now, -1 plus 2, that is, okay, +1. So, what's happening here? T equal to again 2 when you take 2 millisecond. Okay. What is it? T equal to 2 millisecond. T equal to 2 millisecond, this is 0. IR of T, IR of 2 is 0. But IC of 2, you will be getting how much, Nana? Here, how much? IC of 2, okay, how much it is? It is changing from again +2 to, yes or no, all of you? Right? 1.5, and then it is actually at 2, what is happening from +2 to -2, it is changing. +2 to -2, it is changing. So what is happening that I of 2 then, it is also changing from, okay, it is also changing from +2 to -2 because you are adding these two, that's it. Yes or no, all of you, okay? So this is a simple understanding. Just to make you understand, I'm trying to show you this. Otherwise, simply if you see that, it is clearly shown while superimposing here, it's very clear this particular point will be raising up to what? Yes or no, because the +1. This is what actually 0.5. If you add here, what's happening? Plus. Okay? Then it comes to what? Down. Then again what? Okay, increasing. So if you look at this particular waveform and this particular waveform, there is a lot of difference. What's happening here? It is decreasing initially. If you take it as a starting point here, okay, it is decreasing. But what's happening here? It is increasing because it is increasing, and this is positive value. This must increase. So if you observe the D option, what's happening? Increasing, again decreasing here, negative, then increasing and then decreasing. So if you superimpose what's happening, the points are coming something like this. At 0 point, at 0, you have the value that is 2. Okay. What is actually you have? This is 2. This is 0. Finally, you got what? 2. At 0, this is the point you got. And at 0.5, you got 3. Okay. You got 3. And 3 to, it is actually 2, right? This is 1. And this is -1. And this is -2, let us say. Now, this is what actually going on here. And then it is coming down to what actually? -1. Because it is changing from 3 to -1. Yes, it is changing from 3 to -1. It is 0.5 second. Understand all of you? Okay, it is coming down here up to this particular point. After that, what is happening here? 0.5, 1, 1.5, then 2. Look at this. Now, at t equal to 1, what is happening here? The I of 1 will be -2. Yes or no? I of 2 is -2. That means here somewhere. At t equal to 1, I of 2 is -1. That means it's something like this. And at t equal to 1.5, at t equal to 1.5, okay, what is happening here? 1.5, you're having -3 to +1. See, 1, what is happening here? At 1, you have -2. That means I have taken -2 here. Then at 1.5, what is happening here? Here, -3 to +1. Where is -3? Again here, okay, -3. That means it is going up to actually here, okay, up to here. -3 means this is +3, right? Okay, this is +3 and this is -3. Let us say -3, and I'm going up to this extent. Okay, I'm going up to this extent. This is -3. Now, what is happening? -3 to +1. That means up to what? This particular extent. You are going up to this particular extent. Okay. That means it's something like this. Right. Then what is happening here? T equal to 2. It is going from, okay, 2 to -2. Okay. 2 to means what? It is actually going up to 2. Then it is coming down to -2. Okay. This is coming down to -2. Understand all of you, okay? So what's happening here? The waveform shows like, it is increasing and then decreasing, then decreasing. Like this it is going on. Understand all of you, okay? So this is how you can go with.